You still
Yeah, I got money for you right here in my pocket. $10.
Yep. Thanks a bunch.
I forgot to give that to you.
Yeah, don't worry. Grab it.
I get so involved in class that
Just get involved in math. It's hard not to get lost in math, huh?
little hope. Okay, Hope, you want to get the door? All right, I'm gonna take roll. Yeah, this is cool. I can see you too. I can see your smile through your mask. Okay, let me take some roll here. Why am I not? All righty. Rena, are you here?
Yep.
Zach?
Here.
Alex? Excuse me.
Here.
I know you have a sore throat, so or didn't feel good. So, Caleb,
Here.
Sarah,
Here.
Gabe,
Here.
Lily,
Here.
okay, Tucker,
Here.
Grayson, Grayson, Karina. Yeah, Gibbs is gone. That's half my humor. No, I shouldn't say that. It's been recorded. He just makes me smile. God, I'm being mean. All right, sorry about that. See, there's this 13-year-old boy just buried in here, and every once in a while, he comes up. Okay, Ella.
Here.
William, I talked to. Bailey, I talked to. Sophia.
Here.
Oh, okay. Jaden, I see. Morgan Schreifels right there. Morgan Schreifels. God, you just look like somebody else. I just can't get over that. Jordan Smith, Audrey, and Hope. That's everybody. And Jaden, did I say your name? Okay, good. All right, anybody I missed? No. All right, let me hit save. And I can get rid of that. I can get rid of that. I can minimize that. That would be good. And we're all here. And the people in the abyss, did you all get an email from me with your quiz? Is that correct? Anybody not?
I don't think I got an email.
Who's this, Sarah?
Sure, yeah.
All right, Sarah.
I
Oh,
also
Sarah,
didn't-
maybe none of you guys did because I corrected them. Oh, I'm actually okay because when I got home, I had my new stylus, and I don't know where I put it. I'm sure I lost it already. My new stylus, and I corrected them all online. So you guys should be able to pull them up with my notes, of which my wife said you all still have ugly handwriting, but it's not as ugly as it was. Okay. So yeah, you guys didn't get an email because I had already done them all. Correct? Right? And Alexis, you turned yours in yesterday and you should have got it back from me today.
Okay, I haven't looked yet.
Okay, so I'm going to go over the quiz. That's what I'm going to do. Okay, and again, if you have something that you need to argue about, you guys can argue in person. I mean, that's the advantage you have. Okay, that's like the coolest mask I've ever seen, Karina. Did you make that yourself or did you purchase that? The one you got on your face? Yeah, your mask. You made it? Yeah, it's cool. Okay. Are you a seamstress? Okay. I sew buttons by hand. And it's a good thing to have a thimble. Do you know what a thimble is? Okay. So you guys, you may want to pull them up. They're in the abyss, and we'll be going through them. Okay. I got to make sure I got everything I need. See what's nice is your democracy says right. That's a good thing. I don't know how to do
Is that a backwards clock? I
Yes.
just realized that.
that used to be the only clock I had in here. But you know, back in the day, you remember when they would give you tests? Okay? They would test in here, and that was the only clock I had. Oh my gosh, the counselors would be mad. We can't tell time. We can't tell time. Okay? Just requires a little effort. So they made me change it back. I was angry. So I'm going to go through this. I guess I'll do it in green. What the heck? That looks terrible though, doesn't it? I don't like it. See if I have a white copy. I thought I had a white copy. All right, I found it. So we'll go through this. And I'm going to need to share the screen with you guys. All righty. So it was worth 17 points. The first thing, all you had to do is, when I take the derivative of f, there's a couple of ways to look at it. This is 0. This has an exponent of 1. 1 times a -9 is a -9. X to the 0, you get -9. That's one thing. You just had to write down a -9. I did not want you to use the limit definition. You could also argue that this is a line and a tangent line will coincide on that and have the same slope, which is a -9. This is the work that I wanted to see. So I need to see this limit to begin with. And I put x plus h into here. Some people forgot to have the parentheses here. Then I multiplied. You didn't have to write the limit, but I had to see the correct algebra. So I'll comment on that a bit. So this is what x plus h is expanded. It's x plus h times x plus h. That's why you have 2xh. Then I distributed the minus sign through and got rid of these because they're opposites. I was left with this because I was able to factor an h out. Some people wrote a negative h, which you could do, but when you simplify it, it's got to be a -1. And you should have ended up with a -2x. Now, you could have just looked at that and used the power rule to see that it was going to be a -2x. Does everybody understand that? But if the algebra that you used in the limit was no way come up with that answer, I don't give you credit for that. The algebra has to match the answer because the answer is already apparent. Does everybody understand that? All right. This right here, I had equation bolded and underlined. And Jordan Smith, what two things do I need to have an equation of a line? And I gave you the point. So you had to come up with the formula of the derivative. So this is x to the -1 power. And when I multiply that, I get a -x to the -2, which is what this is, because this isn't very helpful to figure out the slope. And then I plugged in 4 and I got -1/16. So you could have put 0.25. I like fractions, so I wanted a fraction. And so that's what I had. All right. This is not what I want, though. All righty. A lot of you said concave down parabola is a -x². And when I take the derivative, you're going to get a negative line, a -2x. Okay, which isn't technically correct because I could have y is equal to a -3x². I could have y equals to a -7x². In other words, f could be in the form of ax², where a is less than 0. So when I take the derivative, 2a would be less than 0, which would be negative, and that's why it has to be this. Okay, that's the more technical one. But I was looking that this was chosen, and then the appropriate where you talked about that you would have the derivative be negative in some fashion. That's what I was looking at. Okay, does that make sense to everybody? Okay, you had to be in sentences. You had to use words. You could use math symbolism. This, you just simply had to use the power rule. Again, I tell you not to use the limit definition. Here was a little tricky, Karina. Did you notice I gave you a point? So that means you had to give me a number as an answer. And so when I took the derivative, I get the derivative of 3 sine t is 3 cosine t plus 4. The -1 goes to 0. I plug in 0, 3 times the cosine of 0 plus 4, the cosine of 0. Now, you guys got to use your calculators, but this is a non-calculator problem because they expect that you know that the cosine of 0 is 1. And so you're going to get 7 as your answer. I could not have 7 without any work. I will give you 1/10 of a point. This one, you just had to take the derivative. It doesn't give you a point. So I took 1/2 times 3 and wrote 3/2. A lot of you said 1.5 because you love decimals. I don't like decimals. I like fractions. And then x to the -1/2 power minus the derivative of sine is cosine. You could have had this. Some people put 1.5 in the numerator and the square root of x in the denominator. Okay. This one says determine the points. Oh, I wish Gibbs was here. I'd ask him this question, but he's not, so I can't ask him. But I can ask this person. Caleb, what's a point?
A spot on the graph?
Yes, it is. That's a good definition. And since we're in a coordinate plane, right, where we have 2 axes, we use 2 numbers to represent them, right?
Yes.
What are those 2 numbers?
The X and Y.
The x and y. You guys know their real names? The ordinate and the abscissa. That's the x coordinate and the y coordinate. Because it doesn't have to be x and y, right? It could be t and q, but so their general names are abscissa and ordinate. Back in the 60s, you used to have that memorized. Now we don't care. What? The ordinate is the x and the abscissa. I just like the name abscissa is the y. So what now? It says has a horizontal tangent line. So Bailey, a horizontal is like this. For the people here, I'm trying to be straight across, right? What slope is that? 0. This derivative gives you slope. So I made it equal to 0. Because I'm asking at what point 0. You could not give me a graph. So you had to take the derivative, and which was 3x squared plus 6x, and then I factored out a 3x. That means 3x could equal 0, which meant x equals 0, or x plus 2 equals 0, and x is a -2. Have you guys learned how to factor? Okay, where you take the greatest common factor out? And then that's not my answer. Because Jordan, it's just the ordinate. We're missing the abscissa, which is a lot cooler to say than y value. But so all you had to do is plug 0 into here, and you get 0. And when I plug a -2 in there, I get -8 plus 4 times 3. 4 times 3 is 12. -8 plus 12 is 4. Now you could use your graphing calculator to confirm that, but I need to see this work. Average rate is the slope of a secant line. I need 2 points. I get the 2 points by putting a -1 into F and a +1 into F. When I put in a +1 to F, I got 2 plus 4, which was 6. When I put a -1 into F, I got a -2 minus 4, which is a -6. 6 minus a -6 is 12. And then down here at the bottom, I had to take 1 minus a -1, which is 2. And 12 divided by 2 is 6. You could have had a -6, a -12 divided by a -2. But it's the slope formula or the difference quotient, it's called, to get average rate. You need 2 points. You had to create 2 points. The instantaneous rate, you had to take the derivative and plug 0 in, and we got 4. Number 2, they had to be different and continuous. So you had to have someone with a point. You could have chose a different one for a point. Here's one of my favorite ones. Right here's where C would be. That has a point, right? If I slam my hand onto that, it would hurt. These are the same type of graph. They're pointy. This one's not pointy. Somewhere in here has a vertical tangent line. So it has to briefly be up and down. It's easier if I do it like this and then draw the x-axis. There we go. Some of you had this. Unfortunately, there's no vertical tangent line in there. So it's got to be a little bit tightened up on that. So I think I took off 0.2 of a point if I didn't think it was appropriate. And then some people don't erase and they kind of scribble and I'm supposed to figure it out. You guys got to treat me like I'm an idiot. It's not hard to do. Okay. Number 10, you just had a copy. And so we're taking the derivative of cosine. So we're using the derivative definition. Pardon? Is that better? And so I wrote this. And then I did my algebra over here. And see, I never give myself enough room. I'm a person with, like I buy too much furniture for our house. We've got chairs we don't even sit on, nor would you want to sit on them. They break. Why do we have those chairs? This craziness. Okay, so I expanded this using a trig identity, and then I flipped them, and then I factored, and then I rewrote this limit, and I took the limit of each one of these four things individual, which were these. And 0 times a negative cosine is 0, and 0 minus sine is a negative sine, and I'm done. Okay. We did pretty well on this. What is C? A lot of you guys said 3. Even if you don't know, just guess 3. You got a chance. Okay. Usually 3 is one of my answers, just because I love it so much. Okay. If you haven't figured that out, 3 is an awesome number. It's like third, so it becomes number 1, which is cool. And then you just plug 3 into this. And I got 177. Some people got negative 177. I have no idea how you did that. Then I took the derivative. I don't know what this, this is supposed to be 9, because I didn't know how to take 3 times 3. So I scribbled this like, it's a guy thing to do. There are very few females will scribble. And then I plugged it in. I know you guys use the calculator, but I'm worried, so that's why I do that. And I had 335. Some people plugged in 0. You just said C was 3. Or they plugged in 1. 1 is not nearly as cool as 3. 0 is pretty neat, 0 is better than 1, but it's not as cool as 3. Just saying. So there are 17 points. So then I subtracted the number wrong from 17, divided by 17, moved the decimal 1 place. So it was out of 10 and rounded to the nearest tenths place. So if you actually look at those numbers and subtract from 10, like they say in Wabasha County, you be wrong. Okay. So I'll come around. If you guys in the Abyss have questions, just send me an email. If you could take a picture of it and attach it to that, that would be wonderful. A couple of things. If you have an iPhone and you take a picture with your iPhone, you got to change the format. So you go to camera under settings and change it from high performance to compatible, and it'll send it to me as a JPEG. Then I can correct it with my stylus on an iPad. Why an iPhone will not talk to an iPad, I don't know. They both start with the letter I, but it's imaginary, so maybe that's what it has something to do with it. I don't know. Did you know at one time they were thinking about calling it the imaginary phone, but they didn't think they would be able to sell very many of them? I just made that up. That is not. I wish it was a lot fewer. I think we'll ask too. She made that for you? Oh. My wife wishes she was a grandma, just to make face masks. Well, she doesn't use her. We have another thing. We have a sewing machine. She never, I'm sure maybe recorded in the abyss, but she never looks in the abyss. We have a sewing machine that sits in a corner and she doesn't use it. Why do we have a sewing machine? Why do we have furniture that no one sits in? No one argue?
No,
Sure.
positive.
I kind of miss that.
Yeah, sorry about it. Next time, Booger.
I really feel like a 13-year-old. All righty, notes, that's where we're headed. Oh, did I hand you the 2-4 notes?
No.
I'm gonna do that right now. Do you have the 2-3 notes?
Yeah.
So. How many people consider themselves responsible? Raise your hand. That is wonderful. I don't consider myself responsible. If you're a responsible person and you think, hey, we don't have the notes that he's about to talk with, just wander up here. I won't even notice you, and see if they're up here. They probably are. Feel free to grab them or simply say, Kruger, the notes are here. Everybody got that? These are for when we come back. And I know we'll have forgotten everything when you guys come. Well, I won't, but you guys will have forgotten everything. Anyway, I'm glad you guys all feel responsible. All right, we are doing 2-3 notes. And I need to talk to people in the abyss. And just as a review, we did the front page. Is that correct? Ella Nelson. Did we do these 3 problems? Ella Nelson. What's it show in your notes? I can't hear you. I don't have my hearing aids. I keep forgetting.
I don't know my thing.
Why? Were you here yesterday?
No, I wasn't on.
You weren't on the Zoom? Okay. Did I go through these?
We did.
Okay. So you want to get those. I think I have the notes also on Schoology. Okay.
We did everything with the proof.
Yeah. Okay. Excellent. So, who am I going to pick? I love looking into the abyss. I'm going to pick Gabe. I got a question. I'm going to write it right here. What is this thing called, Gabe? You probably can't see it. Gabe, can you see this?
Yep.
Okay. This is called a what?
A derivative.
Perfect. And it has a limit definition. Do you remember what that definition is?
F of x minus f of c
Over x minus c?
over x minus c, correct.
As x approaches c?
Yep.
Yep, that is one of the definitions. That gives us a number, right? That gives us f prime of c. The derivative with c plugged in, some number, okay? Some of you guys aren't doing that. You're giving me the formula for the slope because you're not putting the work in to just plug in whatever the x value is, right? Whatever the ordinate is. What's the other limit definition, Gabe? That gives me the limit formula. Sometimes people use h, sometimes people use delta x. That's my,
Sure. Wouldn't it be the limit as delta x approaches 0
yep,
of f of x plus delta x minus f of x over delta x?
perfect, 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 Gabe, perfect. Okay, Gabe, do you know anybody that is in my class right now?
I know Mr. William Nielsen.
Oh, are you picking him to do this next problem?
Sure, I guess.
Okay,
Sweet.
it's just, that's as random as I can get, which isn't random at all. Okay, so you, William, give me the definition of g prime of x.
Well, it's basically the same thing.
Oh, no, just tell me what it is.
Okay, limit,
And you got to use delta x because Gabe chose delta x.
yeah, delta x approaches 0, g of x plus delta x minus g of x over delta x.
Perfect. I'm assuming you and Gabe were friends at one time.
We were, and
You
we
were.
are actually.
You still are? Okay, good. So Gabe, you're safe. So this is, I'm going to show you the proof of the product rule. Okay, this is the product rule right here, correct? Okay, and we're going to do the proof of it. So how do we figure out the derivative of a product of two functions? So it's going to start out looking like this. The limit, and I'm going to make sure you can see it here, delta x, because Gabe chose delta x, of f of x plus delta x times g of x plus delta x minus f of x times g of x all over delta x. And what I'm going to do here is I'm going to put in a separator. Hope that's my own idea. No one else does that, okay? Because Hope, my handwriting's so sloppy that sometimes gets over onto this side if I don't do that, and students get confused. I just started doing this 2 years ago. So students were unbelievably confused. And on this other side, I am going to do some algebra. Karina, what is the only number I can add to something that doesn't change anything? 0. So I'm going to add 0. Okay? And it's going to look like this. Excuse me. F of x plus delta x, g of x plus delta x. I think it's minus. God, I hate this about my age. Minus f of x plus delta x, g of x, plus f of x plus delta x, g of x. Do you see that this is zeros because this is their opposites? Minus f of x, g of x. I'm going to rewrite it because I didn't give myself enough room. So let me try it again. F of x plus delta x G of x plus delta x, and in fact, I'm going to make 0 a different color, minus f of x plus delta x, g of x, plus f of x plus delta x, g of x, minus f of x, g of x. Okay, so what I've done in pink here is added 0. Those are opposites. And what I'm going to do is, since they have delta x as the denominator, I'm going to set them up as 2 fractions. So over here, these first 2 terms are going to be over delta x, and these 2 terms are going to be over delta x. And then what I'm going to do is, if I look at these 2 terms right here, they both have f of x plus delta x in them. One's in blue, one's in pink. Okay, and I'm going to factor that out. And so it's going to look like this. F of x plus delta x. And I'm going to put in a bracket here. And I'm going to have g of x plus delta x minus g of x. And that's going to be over delta x. In fact, I'm going to write the delta x here. And they're going to write a plus here. And if I notice here, Jordan, do you notice how they have g of x? One in pink, one in blue? I'm going to factor out a g of x. I'm going to bring in a bracket. And I'm going to have f of x plus delta x minus f of x, bracket, all over delta x. And then Bailey, 1 times delta x is delta x, isn't it? 1 times delta x is delta x. So I'm going to come over here, and now I'm going to take the limit. And I'm going to take the limit as delta x goes to 0. Get over here where everybody can see. And I'm going to have f of x plus delta x over 1 times g of x plus delta x minus g of x over delta x plus g of x over 1 times f of x plus delta x minus f of x over delta x. Gabe, are you still there?
Yep.
Okay. Gabe, I'm going to take the limit of 4 different things. Do you see this one I'm pointing to right now?
Yep.
What I'm going to do is I'm going to take 3 fingers, I'm going to hide up all this other stuff. And I'm simply going to take the limit of this. And what I'm going to do is I'm going to scroll. Look at this. The limit of this. Does that look like something?
It looks like it's going to be over 0.
Well, did you tell me this?
Yeah.
So equals means whenever I see this, I can replace it with this, correct?
Yeah.
So notice I see limit, and then I see this. So I can get rid of this whole chunk and replace it with what when I take the limit?
The derivative of x.
Right. The derivative of what? Not x,
Of f.
of f. Correct. So this is going to be f prime of x. Now, Jordan, here's old g of x. It's not affected by delta x. It's always going to be g of x because there's no delta x in it, right? So what's going to be right here? G of x plus. Now, William, I'm going to take my finger because my finger's smaller than 3 fingers. See it right here? I think you gave me that one, right?
I did, yeah.
So I'm taking the limit of this. What can replace this?
So then that's just the derivative of g of x.
That's just the derivative of g of x. Now, let's look at this. Back to Jordan. Delta x is going to 0. In the denominator, I have 1, correct? So I'm not dividing by 0. I don't have any problems. I can go through and say, all right, this is going to be x plus 0.1, x plus 0.01, x plus 0.001, x plus 0.00000000001. Pretty soon delta x doesn't even matter, does it? So it's like it's just being what? 0. What am I left with? F of x. And there's my proof. Q, E, D. Color coded. All right, let's say we have this. H of x equals the sine of x. Excuse me, sine of x, I write 7x. I meant to say 7x. 7x cosine x. Sarah, which of those is f?
7x.
Perfect. So f of x equals 7x. Which of those is g?
Cosine x.
Cosine x. Beautiful. So what is the derivative of h prime? Sarah.
7 minus sine x.
Okay, 7x times a negative sine x, correct?
Yeah.
Okay, plus
Cosine x times 7.
sorry about that, times 7. Perfect. Which you have to write is this. A negative 7x sine x plus 7 cosine x. You do not ever multiply the derivatives of each of those. They have to be separated. Here's the derivative of 7x. Here's the derivative of cosine. Everybody have that? All right, sorry about that. All right, next page. So this one says this, and I'm going to write this at top. Suppose you have a function that is created by the division of 2 functions. So we're going to talk about division. So it looks like a fraction. Now, you want to make sure some things are true about g. First of all, g of x is not a constant. Because the derivative of constants, right, are 0. Everybody have that? And the other thing I would strongly suggest, it makes it life a lot easier, g of x is a binomial or more. When I'm saying that, let's say, I'll show you what I mean. If it's a binomial or more, it means it has two terms or more, right? I think you had an assignment that looked like this. I think. And it asked you what H prime was. I think you had something similar to that, okay? I would not use the quotient rule. I would do this first. X cubed over X plus X over X plus 1 over X, right? Does everybody understand that? Right, I can break them up as 3 separate, which this becomes X squared, this becomes 1, this becomes X to the negative 1, right? So the derivative is going to be 2X plus 1 minus 1 over X squared. Does everybody see how I did that? I just used the,
plus one, or does the one turn into
oh, sorry, you're right, I'm wrong. Thank you, thank you, thank you. I knew it was, you were going to correct me today. I just had that feeling. Okay. Yeah, this should be 0. Thank you very much. So it's just going to be 2X minus 1 over X squared. That's what you want to do when you have a single variable every single time. Does everybody got that? However, if you got a binomial or more, it's going to be different. So if we have this, the derivative is going to be figured out this way. You're going to square the denominator. And on top, you're going to have the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator. That's what this is saying right here. This is neat. What I just wrote up is not neat. So Morgan, we have a rational expression, correct? It looks like a fraction. We have more than one term in the denominator, correct? And it's not a constant, obviously, right? So we're going to use the quotient rule. This is G always, this is F. I'm going to write Y prime here, okay? We're going to get a fraction as our answer. So if we take a look here, they say, okay, I'm going to do a little confession. When I learned this when I was in college, I was really bad at it. And I wanted an A, okay, because I was going to be a math teacher. And I didn't want to be a stupid math teacher, because who hires stupid math teachers? No one does, okay? And so I had to have a way, and I kept making a mistake. So what I did for me, and you don't have to do it for you, but what I did for me to help me remember is I always started at the bottom and worked up, okay? So I identified this, what this was, and I did this first. So what do you think I'm going to write on the bottom? Got it. You're awesome. And that's right. And I never did that. And I'm going to tell you why. And because we're going to want it in, down the road, we're going to want it in factored form. You expanded it perfectly. I never do. Okay. Because you're going to end up having to reverse that down. This derivative is going to be telling us a whole bunch of stuff about this graph. Okay. And so I don't expand it. I stop right there. One, it's easier to write. It's quicker. I don't make mistakes. And eventually I'm going to want it in that form anyway. Okay. But you were right. Okay. And you did that really good, by the way. So then once I did that, what do you think the first thing I wrote up here was? If you look at what the definition says. What? What is g of x? Right, you just write x squared plus 1. And now you're going to take and multiply by what? And where did 5 come from? That's the derivative of f, right? Then it's minus. And you just got done with this one, right? So then you're going to write 5x minus 2. And make sure you put in parentheses. Times, now you're going to come over here and take the derivative of that. 2x. So it's kind of like the product rule, but not, right? The product rule is you leave one alone, you take the derivative, right? And then you take the derivative of the one you left alone times the first one. It's kind of like that, right? So it's easy to get confused. So that's why I needed help. The rest of this now, Morgan, is just algebra. What am I going to do here? Now, Morgan, this is the way that I do it. I know that this is going to become a negative 5, correct? Well, then I'm going to take that negative 5x and multiply it by 2x in my head and get what? Right, a minus 10x squared. Are you okay with that? And I always look for this minus because that's the part where I screw up all the time, okay? It just, when I was a student, that's why I bought a plastic baseball bat. I tell you, your roommate in college thinks you're nuts when you start banging yourself against it. So minus a minus 2 times 2x plus 4x. Perfect. So your final answer is going to be x squared plus 1 squared. And so you got 5x squared minus 10x squared. Morgan? You're fast. And you're done. Eventually, we're going to use this stuff, but right now we're just learning some mechanics, okay? It's kind of like this. I remember my dad showing me when I was a little kid the difference in screwdrivers. We had, in his welding shop, he had different types of screwdrivers. He had the flat, he had the Phillips, then he had one that was a star, then he had one that looks like a hexagon or a rectangle or something like that. And then he had hammers and a whole bunch of hammers, and they got heavier and heavier and heavier. Well, you don't take a hammer to get a screw into a piece of wood. You don't take a screwdriver to put a nail in a piece of wood. It just doesn't work very well. So we're just learning some techniques, okay? I'm going to take a little break because I've got allergies, and I'll be right back. Does that sound okay to everybody? All right, thanks for your patience. All righty. So that's it on that one. We're gonna skip this one. Karina? Have you taken my picture yet? This is your first?
Yeah. I don't know which way it's going.
How do you flip this thing? Oh,
Right
there. Okay, that's not nearly as funny with a mask on. All right, so I'm skipping this one. And I'm going to the next page. And, Sophia,
Yes.
what is the derivative of sine?
Cosine.
What's the derivative of cosine?
Negative sine.
Okay. There's a third one you have to have memorized. And it's going to be the derivative of tangent. Okay. And right now you have no idea what it is. So I'm going to show you something. Okay. Audrey, tangent is also a ratio of what trig functions? Yeah, how would I write it? That is actually cotangent. Yep, perfect. So now it's in that rational form. So that's the stupidest phone call. William, you have something in the activities office that you have to sign.
Oh,
I think it's a check for $150 made out of Charles Absolute Value Kruger.
I'll make sure
And-
it's you. I'll make sure
And Kruger is spelled Kruger.
Okay, I'll make sure I sign it.
So, Audrey, very good. Okay. So we're going to take the derivative of this using the quotient rule. Okay. This is actually the proof of what the derivative of tangent is. In fact, all of these are proofs. Okay. So I'm going to start at the bottom, or you're going to start at the bottom. And what am I going to do with cosine? I'm going to square it. Are you okay that I write cosine squared that way? Okay. And then what else do I do with the cosine? I write it up here on top. Okay. Times, what's the derivative of sine? Cosine. Beautiful. Minus, right? Because that's what you do with the quotient rule. And then we're going to write sine because we already just finished sine, right? Okay, good. And now I'm going to take the derivative of cosine, which is what? Times the negative sine of x. Awesome. Okay, you're doing perfect. Okay, equals. This is cosine squared of x. This also is cosine squared of x. Would you agree, Audrey? Here I have a minus. Here I have a negative. And way back when we first learned about positive and negative numbers, we would change that into a plus. And then I have the sine of x times the sine of x. Now, everything up to that point, we did a little calculus, and then we did a little, early middle school math, right? Now we got to do trig. What is cosine squared plus sine squared? It's my favorite trig identity.
1.
Who was that?
Tucker.
Tucker. Tucker said it's 1. Would you agree, Audrey? So it's 1 over cosine squared. Perfect. Tucker.
So,
What's another name for 1 over cosine?
why can't I think of it? Secant.
Secant. So what do you think 1 over cosine squared is?
Secant squared.
Secant squared. Perfect. Bingo. So the derivative of tangent is secant squared, Jordan. Derivative of tangent is secant squared. Derivative of tangent is secant squared. And derivative of sine is cosine. And derivative of cosine is negative sine. They got to trip off your tongue, just like that. Those are the 3 most common ones you'll see on the AP exam. Okay. Let's take a look at this one. Cotangent, another proof. I like these proofs. Hope, you want to try this one? I'm first going to write f of x as what? And Audrey had given us a hint when she first started, so that was very helpful. Cosine over sine. So the derivative, again, we're going to apply the quotient rule. Tell me what to write. What am I going to do this on the bottom? Can I start on the bottom? Is that okay? You don't have to, but you're right. Sine of x will be up there. But what am I going to write here? Yeah, that's just me being, not flexible. I'm sorry. You were going to have me write sine of x here, and that's okay. And students do that and do it fine. Okay. So sine of x times what? Derivative of cosine. Negative sine of x. Perfect. Minus cosine of x. Perfect. Times the derivative of sine, which is what? Cosine of x. So that's going to give me what? What is sine of x times negative sine of x? Perfect. Negative sine squared of x. Perfect. Minus what? Yep. That all over sine squared, correct? Well, what is this? Well, this was 1, right? Yeah, it's a -1. Can everybody see that's a -1? If you factor out a -1, you'll get this, correct? And so I now have -1 over sine squared of x. I'm going to move that straight up over here. What's my answer going to be? What? What's in front of the cosecant squared? Yeah. Now here is, I'm not very good at memorization. I know this. I know the derivative of sine is cosine. I know the derivative of cosine is negative sine. I know the derivative of tangent secant squared. Okay. Sometimes I forget this one, but I always know this, and I know how to do the quotient rule. Okay. Raina Berry, we're gonna do this one. Give me a quotient for secant x. Again, another proof. What?
1 over cosine?
1 over cosine. Perfect. So let's start using the quotient rule. What am I going to get on the bottom?
Cosine squared.
Perfect. Cosine squared x. And then I'm going to have cosine x, right? Now here's the tough one, times what?
0.
Yes. My 0. Perfect. Because the derivative of constant is 0. Minus, so then I'm going to have 1, right? Times the derivative of
So
cosine.
it's gonna be negative. Oh, negative sine.
Negative sine. What does this give me?
So it's gonna be 0 minus negative sine.
Yeah,
So it's just gonna be negative sine on the top.
I think it's a positive sign. You think maybe it's
Oh
positive?
yeah.
Okay, over this, right?
Yep.
Now, Bailey, I hate to tell you this, but math people think that's ugly. So this is what they do. They write it like this. Well, they start writing it like this. And by the way, Raina, you did a very good job. What's another name, Bailey, for 1 over cosine? Secant. And what's another name for sine over cosine? Tangent. So the derivative of secant is secant tangent, which is, I think, weird. It's itself times tangent. But we get some other weird stuff too. But secant tangent. We are going to stop there. So just a reminder, and I will post this up. You have 2 things due on Monday. One is, has anybody tried the filling of the vase or the filling of the cylinder or filling of the cone? Okay. That I will try to put a video together tomorrow. I'll be home and my wife will think it's humorous. We'll be talking math. Maybe I'll wait till she's out of the room. It's actually pretty easy. I don't think that'll be a problem, but I might just do it anyway. So that's due, and then my walk with Rosie is due Monday. Has anybody looked at that? Okay. Do I walk really fast? I can't remember. You know how long? I think it's an hour, isn't it, that I walk or not? Yeah, maybe. What do I walk? 50 feet in an hour? That's the way it used to be. I can't remember. I don't have it memorized. What? It might have been more than an hour. Yeah. Oh, more. I walked further than 50 feet. Yeah, I have no idea. So, Oh, yeah. I give you some, yeah, because I kind of remember now. So anyway, those things are due by 8 a.m. on Monday, but you know, it's gonna be cold. You're not gonna be playing golf or tennis. It'll be like 40 degrees. Maybe you'll go for a walk in the woods. But alrighty, we're gonna be done, and I have some things to share with the people here. So okay.